Hello everybody. In this video we're going to learn about linear inequalities. So I have one here, y is greater than x plus 2. Similar to the equality or equation y equals x plus 2, there's an infinite amount of solutions. So for instance, for the green equation I could say, well, if x is 0, y is 2. If x is 1, y is 3, and so on. The same is true for the red equation. There's an infinite amount of solutions. So if x is 0, y could be a lot of different things now, right? Because y just has to be greater than 2 at this point. So it could be 3, could be 4, could be 5. If x is 10, y could be 15. Okay, so there's a lot of choices for y to be once you put in x. And so one of the easiest ways to figure out what the graph or what x and y could equal is to show a graph for a linear inequality. But keep in mind, at the beginning of the chapter there's questions like, is 3, 5 a solution to the inequality? And you just have to plug in the values and see if it's true. So is 5 greater than 3 plus 2? So is 5 greater than 5? No. 3, 5 is not a solution, right? So that's the beginning of the chapter. Then we get into graphing. So if you're already good at graphing linear equations from slope-intercept form, this should be very easy. There's just a couple more things to get. If you're not good at that, you should go back and watch that video again and get some more practice. Okay, so graphing this, keep in mind it looks very similar to this, which is in slope-intercept form, right, where the slope is 1 and the y-intercept is -4. So in this case, the slope is 1 and the y-intercept is -4, and so we're going to use those. So I'm going to start at -4, and I'm going to slope up 1. So remember, it's a fraction, so up 1 over 1, up 1 over 1, and so on. And so I get that line, which I'm going to make right now. Something like this. Alright. And now the extra things that you have to do are you have to determine if the line is solid or dotted, because just as if you're graphing like x is greater than 5 on a number line, you have to use an open dot or a closed dot. The same thing is true for a solid line or a dotted line for linear inequality graphing. Let me show you what I mean. So if it's greater than or less than, we use a greater than, less than, or not equal to, we use a dotted line, right? If it's less or greater than or equal to, less than or equal to, or equal to, if you were graphing an equation, it's a solid line, right? And these are both lines. Okay, so this is a greater than, so this is actually going to be dotted. So I'm going to fix that. There we go. So it's a dotted line. And then we also have to do shading. So notice I'm going to plug in a point here. I'm going to plug in 0, 0 to this inequality right here. And when I do that, 0 is greater than 0 minus 4. So then I might ask myself, is this true? Is 0 greater than -4? And it is true. So 0, 0 is a solution to this inequality. Therefore, I know that everything on this side of the line is a solution, and so I shade on that side of the line. Now, just to show you, I'm going to pick a point outside the line. Sorry, not outside, but on the other side. For instance, 4, -2. Okay, so let's plug that into the inequality. So I'm going to have -2 is greater than 4 minus 4. And so that simplifies to -2 is greater than 0, which is not true. So this side is not true, so you do not shade, you don't write anything over here. You don't even write not true. So I know that anything in this red region is correct, not including the line because it's dotted. So any number on the line will make a not true statement. All right, let's try another one. So here we have y is less than 2x plus 3. And so slope-intercept form again. So m equals 2 over 1. B equals 3. So I'm going to start at 3. Slope of up to right 1. 1, 2, right 1, up to right 1, and so on. I know it's going to be a dotted line because it's less than. So dotted line. Oops, what's going on here? There we go. Like that. And then I'm going to extend it out both sides here. Alright. So there's my line. And now I'm going to check which side to shade on. So now I'm going to check, let's see, 0, 0 is usually an easy point to check. It wouldn't work if the line actually touched 0, 0, but in this case it doesn't. So I'm going to try that out. So I'll try point 0, 0. So 0 is less than 2 times 0 plus 3. So simplify that right side, and I get 0 is less than 3. That is true, so I know this point here is correct. It's true, right? And true. So therefore, I'm going to shade on this side. So everything on this side is correct. Everything on this side is not, and so I do not shade over there. All right, and that's it for that. So remember, it's the same as linear graphing, except, or linear equation graphing, except you also have to show dotted or solid and then shading. All right, let's try this next one. Now we have y is less than or equal to 1/3 x minus 4. Again, same thing. Get the slope, get the y-intercept, start at the y-intercept. Now we go up 1, right 3, up 1, right 3. We could also go down 1, left 3, down 1, left 3. Now this time it's less than or equal to, so I'm going to use a solid line. Oops, not that way. Something like that. Alright, now I got to check where my shading goes. So again, I'll choose 0, 0. It's an easy point to check. 0, 0. So 0 is less than or equal to 1/3 times 0 minus 4. With a little simplification, I get 0 is less than negative 4. That's not true. So this is not true. So I'm going to shade down here because this is true. Now keep in mind when you're doing your work, do not write not true. Okay, it just means you don't put anything there. So when something's not true, it means you shade on the other side. All right, let's try another. Here we have y is greater than or equal to 1. So again, this is a single variable that we're going to graph. Don't worry about the blue part yet. I'm going to show that later. But if we're graphing just y is greater than or equal to 1, we need to graph y equals 1. Now remember, that's every point where y equals 1. So here, 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 and so on, just all the way across. Now it's greater than or equal to, so it's going to be a solid line. Alright. Oops. There we go. Solid line all the way across. Now we have to figure out where to shade. Again, I could try 0, 0. So 0 is greater than or equal to 1. That's not true. So the shading is going to be up here. Alright. Now just to show you the difference between a y is equal to or something graph as opposed to an x is greater than or less than would be vertical. So negative 2 is here. So it's just going to be all the vertical points at negative 2. Let's make this a blue line. And it's going to be dotted because it's greater than. Something like so. And then also greater than -2. That's pretty obvious. Anything, because we're talking about just x, so greater than would be on the right side. But you could plug in a 0 here to show that it's true if you wanted. So that shading would be over here. And if you think ahead to systems of linear inequalities, you might get an idea of what that would look like when I show two different graphs on the same grid. All right, last example. Sometimes you're given, oops, I messed up this example. Let's pretend that's not an equal sign and instead a greater than. Sometimes you're given an inequality that is not solved for y. Just like an equation, first we need to put it in slope-intercept form. So we're going to do that first. Divide everything by 2. So I get y is greater than -2x plus 3. Slope is -2/1. Y-intercept is 3. So we're going to, whoops, that's a 2. Okay, here's 3. 3, and then we could go down to right 1 or up to left 1. Oops, that's not 2, that's 3. 1, 2, there we go. That looks good. Now it's going to be a dotted line. Oops, I keep doing that. Blue, dotted. Alright. Something like this. Now we have to determine where to shade. And so the shading is going to be, we can try a point, 0, 0, if we want. And we can just use that in the original equation. So 0 plus 0 is greater than 6. Is that true? No. So this side is not true, meaning this side is true. Okay? And that's going to do it for the video. Thanks for watching.